Great. I hope you had a nice break, refueled some, that's important. We are now at the next stage, I would almost say, of getting humans into space and onto Mars, because the next speaker is going to talk about commercial space and its role in it. George Nield is the one I'm going to introduce to you, but first things first. I would like to mention that George, our next speaker, is an alumni of this university, the George Washington University. Especially I want to emphasize that, as this morning I spoke about Purdue, but Purdue is not the only one who gets out real important special people as a university. George Washington University holds its own in this. Present is the Associate Administrator for Commercial Space Transportation at the Federal Aviation Administration. George holds over 30 years of aerospace experience at NASA and private industry. And so I think having George Nield here to talk about a rare treat. George. You're there.
Thank you, Artemis, and good morning, everyone. Ever since the Soviet Union launched Yuri Gagarin into space more than 50 years ago, making him the first human being to leave the planet, almost all of the significant accomplishments and major historical events that we've seen related to human spaceflight have been carried out by the government. Whether we're talking about the X-15 program, Project Mercury, Project Gemini, the Apollo moon landings, 30 years of flying the space shuttle, or building and living and working on board the International Space Station, it's been the government that has been responsible for planning, directing, and carrying out these missions. Well, going forward, that is not necessarily always going to be the case anymore. We're going to be seeing private industry play an extremely important role in our human spaceflight programs, especially for things like suborbital space activities and in low Earth orbit. But this morning, I'd like to take that one step farther and talk a little bit about why I think commercial space should be a key ingredient to the journey to Mars. First, let me answer a question that you might be asking yourself right now. Why is the FAA involved in the space program at all? And the answer is called for in the law. Based on the Commercial Space Launch Act of 1984, any U.S. citizen that wants to conduct the launch of a launch vehicle anywhere in the world needs to have a license from our office. The only exception for that is for missions that are being conducted by and for the government. So NASA did not need an FAA license to fly the shuttle. The Air Force does not need a license when they're carrying out their national security missions, but anyone else does, big or small, old or new. So for example, we'll be licensing Virgin Galactic and Blue Origin when they conduct their suborbital space tourism flights. We currently license Orbital ATK and SpaceX for their cargo-carrying missions to the International Space Station. That's being done for NASA, but not by NASA. We expect to license Boeing and SpaceX for their missions to carry NASA astronauts to and from the station. Now, altogether, there have been 245 FAA licensed launches over the years, and all of those have been completed without any fatalities, serious injuries, or significant property damage to the general public. So that's a great safety record that we want to keep intact going forward. We actually have a twofold mission in our office. First of all, to ensure public safety during commercial launch and reentry activities. And then secondly, to encourage, facilitate, and promote commercial space transportation. Now, we've been talking about commercial involvement in space for a number of years now. Since the turn of the century, there have actually been 3 different presidential commissions about space: the Walker Commission, the Aldrich Commission, and the Augustine Committee, and all of them have called for increased reliance on private industry. We also have a national space policy issued back in June of 2010, and it talks about how vital the commercial space sector is to continued progress in space. It's important to remember, though, that we're not talking about one or the other. This is not commercial against the government. There's a sweet spot where we can see public-private partnerships that is mutually beneficial, where industry is providing what it does best to the government, and both are benefiting. So what does government bring to the table? Well, a lot of expertise, many years of appropriate experience, a continuing need for space products and services, and an impressive record of successful space programs. Certainly, one of the most successful of those programs was the Apollo program. And from a technical perspective, it's hard to beat. On the other hand, if we look at that program from the lens of it enabling and being a stepping stone on the way to exploring and settling the solar system, I think the results are at best mixed. So that's why it's so important as we talk about going to Mars that we think about what we need to do to have a sustainable program, that we're not just going to have flags and footprints, but can continue on indefinitely. I think it's very interesting to note that some of the characteristics that are likely to help us in making a program sustainable are the very ones that industry in general excels at. There's at least a potential in an industry program to have lower cost. There's a potential for increased innovation, perhaps a greater risk tolerance, new customers, new markets, and even new sources of funding. So if it's that great to have industry as a key part of a space program, how come we don't have increased involvement for all of our government aerospace programs? And the answer is, there's a catch. And the catch is, to achieve some of these benefits, the government may need to change its historical practices and even its culture. Loss of control by the government is something that can be very difficult to deal with. On the other hand, if we're willing to be a little more flexible in terms of how programmatic requirements are satisfied, we have the hope that we could achieve some significant overall advantages. So given that, I believe there are a number of different aspects of our future exploration programs that could be either carved off or looked at as a component of the overall program. That ranges from things like transportation to and from LEO for both cargo and people, transportation to and from destinations beyond LEO, including pre-positioning, supplies, and modules and propellant, telecommunications, weather, navigation services, energy, science data, on-orbit assembly of spacecraft, repair and servicing of those satellites, operation of on-orbit propellant depots, in situ resource utilization, and supplying raw materials. All of those, I think, would be achievable as an industry-led component of the overall program. The government, too, can think about how it acquires those products and services. For example, if the government didn't buy the hardware, it could buy data that it needs to influence its future activities. It can take advantage of challenges and prize competitions. It can use things like Space Act agreements, cooperative agreements, and other acquisition mechanisms to minimize the overhead, give industry more flexibility and ability to use its creativity and innovation. And if it's structured properly, it can even provide incentives for industry to invest some of its own funding, thus leveraging our overall budget. There are a number of examples of how this has been done successfully. We've already heard talk about EFT-1, the Exploration Flight Test 1 mission that was so important in demonstrating Orion's capabilities. That actually was a mission that was not carried out just by NASA. United Launch Alliance conducted the launch of the Delta IV Heavy under an FAA launch license. Lockheed conducted the reentry of Orion under an FAA reentry license. So what did NASA do? Well, NASA was the customer for lots of great data from Orion. They were able to get a lot of information on how the heat shields performed, the avionics, the subsystems, and the systems. So why would NASA? Because using this approach allowed us to achieve that test a lot faster and a lot less expensively than had we used the traditional government aerospace program model. Cargo program, again, the COTS program, Commercial Orbital Transportation Services program, ended up costing in its entirety about $800 million, essentially less than a single space shuttle mission. And for that cost, for that investment, the nation now has 2 launch vehicles, 2 spacecraft, and all of the supporting launch pads and mission control rooms to successfully take cargo to the International Space Station. And we've got Sierra Nevada signed up to join that team starting in 2019. We've got the Bigelow Expandable Activities Module, BEAM, already on the ISS. What a great partnership that is. Bigelow has the opportunity to test out its expandable module in a real-world environment with crew. NASA gets the opportunity to see for itself how that new technology will hold up under actual operational environments, including radiation, vacuum, temperature, excursions, and so forth, for a very minimal cost to the government. We've seen a lot of exciting things in terms of reusable launch vehicles lately. SpaceX has been able to successfully fly back the first stage of its Falcon 9 rocket, conducting a land landing at Cape Canaveral and landing on its high-tech barge off the coast of Florida on multiple occasions now. And you might think, well, isn't there a performance penalty to do that? Why would we want to think about that for a mission to Mars? Don't we want to have everything right at the maximum value? Well, there's a trade-off there for sure. But if reusing stages can allow us to significantly lower the cost in our campaign of mission after mission after mission to Mars, that may be something that plays very successfully in the trade space. Blue Origin has also had some successes in reusability. They have now conducted 3 successful flights with the same vehicle to suborbital altitudes with its New Shepard system. Their plans involve using this system as an upper stage to a much larger booster that would be launched from Cape Canaveral in the years ahead. So once again, should reusability be demonstrated with a system like this on a large scale, then that could play a huge role in some of our future exploration missions as well. We've got the Commercial Crew Program well underway now with both Boeing and SpaceX under contract, and we're counting down to the first activities, which, as I mentioned, will include FAA licensed launches, and that could start as early as next year. There's been an interesting development in the commercial space arena recently in that we're seeing an evolution away from the typical commercial activities like telecommunications satellites and remote sensing, and into some new and non-traditional activities, things like commercial space stations, satellite servicing missions, commercial moon bases, and asteroid mining. All of these are now being seriously looked at. Funds are being raised, not from the government, not using tax dollars, but using private funding sources in an effort to lay out a business case for these as activities that can be conducted in the next few years. Of particular interest to this gathering, of course, was the recent announcement that SpaceX plans to launch one of its Dragon capsules and actually land it on the surface of Mars, with the mission beginning in 2018. And that will be an FAA licensed launch as well, so we're already working with SpaceX on that mission. And there are some interesting policy challenges associated with that. That has to do with the Outer Space Treaty, which says in Article 6, the activities of non-governmental entities in outer space shall require authorization and continuing supervision by the appropriate state party to the treaty. In other words, a government needs to oversee its non-governmental activities in space. If you look at our existing framework in terms of how that's done, we've got three players. The FAA, as I mentioned, is responsible for licensing launches and reentries. The FCC licenses radio broadcasts from space. NOAA is responsible for licensing remote sensing activities, such as taking pictures of the Earth. Obviously, DoD and NASA are key space players, but they're not regulatory agencies. So the question is, what do we do with some of these non-traditional things that don't fit nice and neatly into our existing framework? Well, that's been under discussion for some time now in the interagency community, and it's gotten the attention of Congress. And in the Commercial Space Launch Competitiveness Act, which was just passed and signed into law on November 25th of this last year, Congress directed that the Office of Science and Technology Policy take a look and assess current and proposed commercial activities in space and come up with the appropriate authorization and supervision authorities and recommend an approach. So that has now been done. Dr. Holdren from OSTP sent a letter to Congress on April the 4th, and what it recommended was that the Secretary of Transportation, which by delegation means the FAA's Office of Commercial Space Transportation, our office, would be authorized to grant authorizations for missions in outer space using what criteria? Well, if it were consistent with international obligations, foreign policy, and the national security interests of the United States, and with U.S. government uses of space. We anticipate modeling the process on the FAA payload review process, which is already in place. And the thought is that this would not impact in any way either government activities or commercial activities that are already licensed by the FCC or by NOAA. So the intent is not to be a burden on industry. On the contrary, the idea is to enable industry to proceed with those activities, which right now are sort of in limbo because they don't have the green light from the government that is necessary according to the Outer Space Treaty. There's a lot of other interesting things being discussed on the Hill right now. Some of you may have seen the American Space Renaissance Act, which was introduced by Congressman Jim Bridenstine from Oklahoma recently. It has a full range of space-related provisions in it for national security space, civil space, and commercial space. And they range from things like a 5-year term for the NASA administrator to a requirement for NASA to have a 10-year and 20-year plan, and for Congress to be required to have multi-year funding, which would give a lot of flexibility to NASA for some of its programs. It also talks about the desirability and the benefits associated with having international partnerships in our space programs. And one of my favorite ways to do that was the idea that's been put forward by the Director General of the European Space Agency, Dr. Jan Werner, who's talked about having a moon village. And I think this has some interesting analogies because it's not relying on a single government, a single space agency making the assignments and directing all the shots, but rather collaborating with the entire community, with individual nations and individual companies coming together and participating based on their areas of interest. So this is an exciting time in commercial space right now. We're seeing companies that have the potential to carry out activities that used to be only able to be conducted by governments. If we in the government can be open to new ways of doing business, then I think we may be able to benefit from some of the characteristics that industry will bring, such as lower cost and increased innovation, things that have been historically associated with the private sector. Speaking for the FAA's Office of Commercial Space Transportation, we are committed to working with NASA and other government agencies, with industry, the Congress, and with all of you to ensure that we maintain our U.S. leadership in space. Thank you very much.